For today, I will teach you how to solve problems involving related rates. Related rates problem involves two or more quantities that vary with time and an equation that expresses some relationship between them. I have here strategies for solving problems involving related rates. First is to make a drawing of the situation. Second, use letters to represent the variables involved in the situation. Third, identify all the rates of change given and those to be determined. Use the calculus notation dx over dt or dy over dt to represent them. It depends on the variables that you used. Step 4. Determine an equation that involves. Step 5. Differentiate the equation in step 4. Step 6. Substitute all known values into the differentiated equation. And lastly, or step 7, is to use algebraic manipulation to solve for the unknown rate or quantity. I have here a sample problem to solve. A ladder 10 feet long is resting against a wall. If the bottom of the ladder is sliding away from the wall at a rate of 1 foot per second, the question is, how fast is the top of the ladder moving down when the bottom of the ladder is 8 feet from the wall? Let us now solve the problem. Let's proceed to step 1. Make a drawing of the situation. So I already have a drawing here. This is the wall, and this is the ground, and this is the ladder that is resting against the wall. It is stated in the problem that the ladder is 10 feet long. Put it here. Let us now proceed to step 2. Use letters to represent the variables involved in the situation. So we let x be the distance from the bottom of the ladder to the wall. Say x. And we let y be the distance from the top of the ladder, from here, to the ground. It is stated that the distance from the bottom of the ladder to the wall is 8 feet. Let's proceed to step 3. Identify all the rates of change given and those to be determined. Since we have a variable x and variable y, our rates are dx over dt and dy over dt respectively. Put it here, dx over dt, and here is dy over dt. It is stated in the problem that the bottom of the ladder is sliding away from the wall. The bottom of the ladder is sliding away from the wall 1 foot per second. So it is our dx over dt. 1 foot per second. The question is, how fast is the top of the ladder? How fast is the top of the ladder moving down? It is our dy over dt. The required value is dy over dt. Since the ladder is moving down, we are expecting that our dy over dt is negative since it is going down. So let us now proceed to step 4. You have to determine an equation according to these variables. Since it is a right triangle involving these variables, we can come up with an equation of a Pythagorean theorem, right? So Pythagorean theorem states that the sum of the squares of the length of the sides, these are the sides, is equal to the square of hypotenuse. And this is our hypotenuse. X and Y are related by Pythagorean theorem. So we use that equation. Let us write our equation. X squared plus y squared is equals to 10 squared. And for our step 5, differentiate the equation in step 4. Here is our equation. Using implicit differentiation, differentiate both sides of the equation with respect to t. Here, 2x dx over dt plus 2y dy over dt equals the derivative of our constant is 0. But before we proceed to step 6, which is to substitute all the known values into the differentiated equation, let us first look to the differentiated equation if we only have one unknown. And that one unknown is the required value, which is our dy over dt. Let's check. We have the value of x, which is 8 feet. Our dx over dt is 1 foot per second. Our y, we don't have the value of y, and dy over dt is our required value. Since we don't have the value of y, let us solve for the value of y. We can solve the value of y using this equation, Pythagorean theorem. Say x squared plus y squared is equals to 10 squared. Let's substitute the value of x. 8 squared plus y squared is equals to 10 squared. And let's do the algebraic manipulation. Y squared is equals to 100. 10 squared is equals to 100 and minus 64. 8 squared is equals to 64. Y squared is equals to 36. To find the value of y, 6. Cancel out this. And square root of 36 is 6. So 6 feet. Y is equal to 6 feet. Since we only have one unknown, which is the required value, we can now proceed to step 6. Step 6 is to substitute all the known values into the differentiated equation. I already substituted the values. 2 x, which is 8 feet here, dx over dt is 1 foot per second, plus 2 y is our 6 feet, and dy over dt. Since we already substitute all the known values, let's proceed to step 7, our last step. We use algebraic manipulation to solve for the required value. But let's put it here. Two times 8, 16. 16 feet squared per second. plus 12 feet dy over dt equals 0. To solve for dy over dt, we use algebraic manipulation. Our dy over dt is equal to negative 16 feet squared per second over 12 feet. Our simplest form is negative 4/3 feet per second. And this is our final answer. As I've said earlier, since the top of the ladder is going down, we are expecting a negative answer. So our answer is negative. And that is how to solve a problem involving related rates. Don't forget to like my video if you have learned something. And don't forget to subscribe to my channel and hit the bell button for more videos.